Do you use Kubernetes? Do you use managed Kubernetes? Do you use Kubernetes across different cloud environments? Do you feel that there is a need for cost solutions so that you can monitor the cost, optimize the cost for the services you are running? And this is what we'll be discussing in this video using a tool called Cast AI. So, hello everyone, my name is Sam Parhak and you're watching Cube Simplify. Now, what happens is over the past few years, especially with the economic slowdown, the need for visibility into the Kubernetes clusters and the costing aspects have increased a lot. And that's why we have FinOps Foundation. FinOps is a evolving term. It means it is a kind of shared responsibilities between different set of teams for different cloud providers where your applications are running. So let's say you have a cluster which is running on AWS, and that EKS cluster is incurring a lot of cost. Now the issue is most of the time you are over provisioning resources. It's the case more than 90% of the times people over provision the resources than they actually need. Whether it's nodes, whether it's for the application that you provision the replicas of the pods more. So you always would over provision because it's difficult to predict what is coming in. And you can do bunch of things, like you can have your set of algorithms to measure the inputs for the application, the number of requests that comes in, and then over a period of time you will have a good sense of how much compute power you should be giving it. And with the modern AI system coming into the place, this has evolved to a bigger problem because now you need GPUs are costly, so you can't over provision the GPUs. It will cost you a lot of money. So you need a solution that gives you complete visibility onto the Kubernetes clusters. What are you using? What is the cost per namespace, per team, per tenant inside the Kubernetes cluster? You need the visibility from the security angle. You need the visibility from the sizing perspective. So all these visibility are pretty much required, and Cast AI is one such tool that actually promises to cut your Kubernetes costs in half. And it's kind of a all-in-all platform for Kubernetes automation, optimization using the right sizing techniques that it has built in. So although it is a platform that you need to sign up, and the sign up is free, you don't need credit card. Only some of the services goes into the paid section, but major ones, which is the Kubernetes cost monitoring, which is really dope, and the container security comes for free. And then some of the very intelligent features like the hibernation and the auto scaling, they come into the paid platform. So we'll go through all of it and let's discuss all about Cast AI and see it in action. So this is the Cast AI home screen. So as you can see on the main, when you log in, so it's a regular sign up that you do using your email or Google Workspace account. I have already logged in and this is my profile. And as you can see, you have a cluster list option where you have the list of the clusters. There is a demo cluster which is already there. So if I click here, I can see the demo cluster, and in the demo cluster there are a lot of options that gets enabled. So you get a dashboard view, you get the cost monitoring with respect to cluster workloads, namespaces, allocation groups. Then you will be able to see the available savings for this, and then some of the other things. So what we will try to do in this particular demo is we will try to connect a new cluster and then try to do everything from scratch. So let's go to the home page. So that's the home page. There's one demo cluster which is already there, which is very good. I think it's good for understanding for the longer running clusters. Like more and more you use the cluster, you'll get more and more good metrics out of it, more and more intelligence out of Cast AI. First, what we'll be doing is connect a cluster. So we click this simple button over here, connect a cluster. So I already have provisioned an EKS cluster, which is there. You have bunch of other options as well. It has native integrations with AKS, GKE, and others. So let's click next. A simple script that you need to run. So I'll copy it and I will run it against my shell. And it has created the namespace, resource, quota, service account, cluster role binding, all that stuff, plus two new deployments. One is the Cast AI agent and one is the Cast AI agent CPVPA. So those are the Cast AI components. Now I go back, I say that I ran the script over here. Great, the demo cube simplify cluster has been connected successfully. We can see over here we have the demo cube simplify cluster. Let's click demo cube simplify. It is still analyzing because it just got installed. It will be getting all the metrics, and we can see that over here now we have some of the things which are enabled, but some of the things which are not enabled, like the autoscaler, rebalancer, audit log and stuff. So what we'll do is we'll go to the dashboard. It has analyzed and given a first glance. So the first glance is saying that the cluster status is right now in the read only mode. The region, connection, how many nodes are there, how many pods are there, how many pods are scheduled, what is the over provisioned CPU, how it looks like at the first glance. It's a fresh cluster. There's nothing installed over here. Now, coming to the available savings section, from the glance says that you have a cluster and you can save 27% already. So the cluster compute costs that comes out is, if we are using only EKS, where that comes out to be around $60. And if we use EKS plus cost AI, it will be down to $44, which is 27% of saving. And who doesn't like saving money? I mean, that's just a very small two node cluster, and that's why the costs are pretty low. But if you have huge, massive Kubernetes clusters that you're using in production, dev stage, production, different environments, that brings down a cost to a very significant level. And there are a lot of things which are right now not enabled or you cannot use immediately, because when I click start saving now, it asks me to enable cast AI agent. So this will be enabling some of the enhanced features of cast AI. So I'll copy this, and I'll also enable security, which is a new beta feature, and I paste it over here. And as you can see, it installs bunch of things onto this clusters. So it is creating new roles, new instance roles, attaching policies, and then deploying cast AI cluster controller, spot handler, cast AI evictor, and all the other components that you can see by doing kubectl get pods -a, which is for all namespaces. And you can see in the cast AI agent namespace just a few seconds ago, these are the set of components that it installs. So you have cluster controller, you have kvisor, you have the agents. Everything is now installed and configured correctly to enable all the stuff which was not enabled previously. So now you can see it automatically detects that we have ran the script. I do done, and all these rebalancer, security report, autoscaler, which were earlier grayed out, are now available for you to use. So let's try to understand and break it down. So first we went through the dashboard. It gives a neat view. Let's go to cost monitoring, because that is where we want to understand the granular details from the cluster, and it actually gives you a drill down detail for a lot of things. So you first have the cluster overview. So this is the overall cluster overview of how things are going on. So this is the compute cost. You can also see the egress cost, which is missing. You can also see that there is a documentation. You can install it, and you can also go to the efficiency, like what is the current over provisioned CPU, what is the current over provisioned memory out there, and you can see all of those information as well. Coming back to the compute cost, you can see that this is the provisioned CPU cost and this is the provisioned memory cost. Since these are the on demand, so this cost is same. And when we enable some of the other things like spot instances and fallback mechanisms that I'll be telling you, like if spot instances do not behave well in terms of the performance of the application, then probably it falls back to the on-demand instances, and we will be able to see some of the metrics over here as well. So what we are going to do is, let's see the workloads. We can actually filter. Now this is the very cool part. So we can filter by namespaces. So right now there are two namespaces. We can filter it by the labels. So if we want to see on a particular namespace what is the cost coming out, so it gives you the total cost per namespace for the workloads. It actually has namespace already, so you don't have to do it, but it gives you the workload wise cost as well. Like if you want to see the cost of a particular workload, it gives you that. Then allocation groups. So right now there are no allocation groups, but if you want, we can create an allocation group and we can specify over there, and we can see the spends of those groups. And then cost comparison, we will be able to to the cost comparison as well. Since right now we don't have any historical data, so we are not able to see this. But if we see in the demo cluster, we will be able to see something. So that was the cost monitoring. So we have seen cost monitoring. The next feature that I want to show is the autoscaler. Now, what autoscaling basically means is whenever you are creating a workload and certain pods fail to get scheduled on the nodes because of the insufficient number of CPUs or the memory which is available on the existing set of nodes which are connected to the Kubernetes cluster. So you might have a cluster autoscaler, you might have a thing like Carpenter that automatically scales up based on the autoscaling group configurations and stuff like that. So it is another intelligent autoscaler which is there. I mean, you will be able to compare the Carpenter one with Cast AI. Carpenter is the open source automated node provisioning and the deprovisioning, and it is effectively, like, it's very effective, but it's only supports like EKS, whereas Cast AI has the intelligent autoscaler that supports multiple cloud providers. Plus, Carpenter does not involve the cost aspects with respect to the autoscaling, and Cast AI involves the cost optimization aspects. It comes to the autoscaling because it does all the observability for cost and all those things. Anyways, so what we'll try to do over here is, so first is the autoscaler. So now in autoscaler, it is unscheduled pod policy. So automatically adjust the size of the Kubernetes cluster so that all pods have place to run. So if I run some amount of replicas, it will be automatically creating a node size and then connecting the node back to the cluster and making sure that the pods are always running. Instant life cycle, we can have on demand or spot instances are pretty good because they are pretty cheap, but they are also not reliable because they go away very soon. There is another option which is called, which I was showing you in the other tab, which is called spot fallback. So if the spot instance is interrupted and inventory is not available, temporarily schedule the affected pods using the on-demand nodes. And now there's another prediction model, which is the enable interruption prediction model. So predictive rebalancing will handle notifications about upcoming spot interruptions and replace affected nodes. I think that's pretty good. They are increasing all these things and now diversify the spot instances. Instead of choosing the most cost effective instance, autoscaler will check the composition of the cluster and select a node that increases the diversity of instance families in the cluster. The action results in an increase in compute cost. So there will be an increase in compute cost, but it will select best based on the diversity of the instance families inside the cluster. Architectures, we enable both. We don't need GPUs at the moment. That will be it. And right now, I think it shows that based on the current market availability, 674 instances are available. It has all the stuff that is needed to run. So we save the changes. So that's our template that we have created. Next is the node deletion policy. So this policy will automatically remove nodes from your cluster when they are no longer have scheduled workloads. So this allows the cluster to maintain a minimum footprint and reduce cost. So what happens is, so when it rebalances, so it will put all the nodes and try to effectively and efficiently use all the nodes of the cluster and make sure that the remaining nodes which are freed up, it can delete. So we can have a node deletion policy and we can have a TTL setting for that. So let's keep it default because it's not something we need to take care or think right now. Next is the CPU limit policy. So keep the cluster CPU resources within a defined limit. The clusters cannot be scaled up above the max limit and below the min limit. So if you want to have certain CPU limits applied, there's a maximum cap for the CPU limits irrespective of how much workloads come in. There can be a blast of workload somebody hacked into and create like thousands of pods, and also a minimum count over there. So we are not keeping it now, but that's a very handy feature as well. So we save the overall changes. Autoscaler changes were saved successfully, and our node template came here, and this is the node configuration. If you see, this is what it generated, and then the node configuration, this is what it generated. So now we have the autoscaler over here. Now let's go back to the available savings. So now we are coming to the available savings. So it says we have 2 out of 3 autoscaler policies enabled. We have currently $60 monthly based on the compute costs. We are still in the optimal saving zones because it's a very small cluster. We don't have any workloads on it and things like that. But the workload right sizing is available. Now let's look at some of the other options. So first I want to show you the auto scaling in action. So what we'll do is kubectl get pods hyphen a. We will try to create kubectl create deploy nginx hyphen hyphen image nginx hyphen hyphen replicas, maybe 100, and kubectl get pods hyphen a. Let's see if it's able to create. If not, then it will show in pending. Okay, some of them are in the pending state. I hope it triggers the auto scaling. Let's go to the dashboard and we can see view unscheduled. These are the pods which are unscheduled pods. So we can see when we describe a pod, it says that no nodes are available. So ideally it should try to scale. It should intelligently use the autoscaler to scale it. So let's see what is happening. It says that there is 0 out of 2 nodes which is available, and I don't have access to all the accounts which are there. Like I don't have access to all the node sizes for this particular account. It's limited. But as you can see that as per the autoscaler configuration and as per the number of pods which are left, like 85 or something, it requested for a C6A 4x large on demand instance, and it has failed because of the obvious reason, but the autoscaler is doing its job. So what we'll do is we'll delete the deployment kubectl delete deploy nginx. So that's how the autoscaler would work. So the two important things that were launched very recently are the workload right sizing and the precision pack. So these two are the things which was just recently launched. So workload right sizing is basically setting your workloads to request the right amount of resources to run smoothly. Obviously in Kubernetes, once when we started initially this particular conversation, we told that we are always over provisioning of the resources or not actually provisioning it right, because we see some out of memory errors and things like that. But with this, workloads are right size using the request and the limit for the CPU and the memory, and it avoids issues like the OM and CPU starvation, pod eviction, and things like that. And when we cut the over provisioning of resources, we cut the expenses, and who doesn't like to save costs? And Cast AI helps you to do it in a much better way because it gives you all the details. Like when we see in the dashboard, we can see in the workload right sizing section that the current efficiency is sitting at 20.09%, and it can still save us $10. So what we can do is Cast AI automatically gives us all the recommendations. So we view it. Let's go to one of the recommendation like Nginx, and when we see, it gives us the patch command to be applied so that we don't have to judge. It automatically detects and gives us this particular patch command, and that can be applied onto the cluster for this workloads. And if we apply for all, we would be able to see in the workloads efficiency that all of the pods are used in an efficient waste and nothing is being wasted, and we are saving more and more and more cost over here. Next up is rebalancer. So rebalancer is nothing but it rebalances your node to achieve the most cost efficient setup, and Cast AI will replace the suboptimal nodes with the new ones to move your workload here and there effectively, and only nodes that are marked ready without any problems are considered for rebalancing. So you can always try generate a plan, and it is generating a kind of rebalanced plan to see what will be coming up next. It works pretty well when you have more number of workloads and you are running it for a longer duration of time. Since this is the new cluster, so the rebalancing is not making that much sense now, but it actually is a very powerful feature as well. And then is the node list. So this is the node list which is there, and this is the audit log from where we saw that the autoscaler did work, but the adding of the node was failed. One last thing that is there is the security report. So we can check the security report for the cluster. Again, this is kind of the beta feature. And if you remember, when we installed Cast AI, it automatically installed a Kube bench. So it is using Kube bench to detect the CVEs, giving the best practices. So what we can do is we can see some of the best practices for this particular cluster. So it detects with respect to the CIS benchmarks what all is using privileged container, access to create pods, and all these. And then if we go for the high severity ones, so it tells for the privileged container the details, the remediation procedure, and the affected resources. For this we can directly see the vulnerability mapping as well. So for example, this particular cluster controller Cast AI library or the metric server library is actually having one of the high vulnerabilities, which is this. it gives the CVE score. It also points to the CVE number, like this is the CVE number which is there, and you can see what is happening and if you want to fix it. Usually the criticals and the highs, like there is a chance that only 15-16% of those actually matter. Still a good starting point of getting total vulnerabilities, where it is attached to which particular workloads it is attached, and you can work on fixing those based on the prioritization within your organization. So that's pretty much it with respect to Cost AI. Do give it a try. Let me know if you're using something additional with respect to Kubernetes cost, or in general about how you feel about FinOps. And if you're using Cast AI, then let me know how you are using Cast AI. And if not, then try it out. It's a pretty dope product, and I would say it gives you a lot of intelligent features out of the box for different cloud providers, including your AWS, GCP, AKS, and even OpenShift. So a large amount of integrations are already in place. I hope you like the video. Check out Cast AI for sure. And do not forget to like, subscribe, and share, because FinOps is something you would like to share with your network as well, for those who are using Kubernetes clusters. Thank you so much for watching this video.